Welcome back to Math with Patrick. Today is June 20th, and we're solving problem number 171 from this Daily Epsilon calendar. We need to show why this fraction is equal to 20 for today. So I see, well, it's a fraction. There's a numerator, there's a denominator. The denominator is a really long sum. Looks like there's 17 different terms, all different powers of 5. And up top, we have kind of like a simple little difference here, although 5 to the power of 18 is quite big. So if we just study our powers of 5 for a sec, you'll probably notice that they grow pretty quickly. So 5 squared is 25, 5 cubed is 125. The next ones I think are 625 and then 3,125. And that's only 5 to the power of 5 right here. And we need to go all the way up to 5 to the power of 18. That's going to be a pretty big number, and I don't really want to be doing arithmetic with numbers that large. Instead, I want to see if I can find a way to kind of cleverly use this sum on the bottom. And I do know that there's some kind of relationship happening here. I think, first off, let me just call the sum S. And this is just going to be the denominator as is. So 5 to the power of 16, 5 to the power of 15. There's going to be a 5 to the power of 14, 13, 12, all the way down to, 0, because 5 to the power of 0 is 1. And I'm just writing maybe a few more terms in my sequence than is in the denominator, just to kind of show my point. And I think the best thing to do here is see what happens when we multiply the sum by 5. So if you imagine doing that, then that 5 on the outside here will just distribute into all of the terms. And so 5 times our sum is going to be 5 to the power of 17 plus 5 to the power of 16, 5 to the 15, all the way down to 5 to the power of 1. Because again, we're multiplying a 5 into all of these terms, and then 1 times 5 is just 5. And I want to see how I can relate this to the numerator. The reason why I multiplied it by 5 is that I know of this strategy where you have a long sum here, and if you try multiplying it a little bit and then subtracting the two, you're going to basically cancel out all of the middle terms. Oh, cool, just joined me. So if we try doing 5s minus s, that's going to be the bottom sum minus the top one. All of these terms in the middle are going to cancel out because we have a 5 to the power of 16 in kind of that first sum, and it's going to cancel out with a 5 to the power of 16 in the previous sum. And so all of these are going to cancel. There's a 5 to the power of 14 in those dots. And then 5 cubed, 5 squared, and 5 to the power of 1 are all going to cancel. And so we're just left with this expression, 5 to the power of 17 minus, I'll just call it 1 actually, minus 1. So if we simplify the left side a little bit, 4s is equal to 5 to the power of 17 minus 1. Now that doesn't show up in the numerator just yet. It's not exactly the same, but let's factor out a 5 from the numerator. So we can factor out a 5 from the first term. Instead of 18 5s all being multiplied, we only have 17 5s. And then doing a minus 1 is going to be the best number here, because if you imagine then redistributing this 5, 5 times minus 1 is minus 5. And there is that 5 to the power of 17 minus 1 that I wanted. And honestly, in the bottom, I'm not going to rewrite the whole sum. I already have a nice variable for that. That was just s. So I'll put s in the bottom. Oh, and then 5 to the power of 17 minus 1, that is just 4s. And so these s's cancel. S is just basically this number in the denominator. Not really sure what it is, but I do know that I can cancel it on the top and bottom. We're just left with 5 times 4, which is equal to 20. And that's today's date. So there is my solution for today's problem. I hope you enjoyed, and I'll see you in the next video. Alrighty, bye-bye.